Okay, so hopefully you remember right before we left school, we were learning about minerals. I loved your shoes, by the way, one of my favorite projects of the year. But, anyways, we had 5 rules for all minerals. They had to be solid, right? No water, no mercury. They had to be natural, no plastics, no rubbers. They have to be inorganic, the same thing as abiotics. They can't be alive, so no pearls, no teeth, no coal. They have to have some kind of crystal structure, right, which is just a repeating pattern of their chemical composition, that chemical formula that they have. So it's just like CaCO3 repeated, 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 repeated. And then we get these beautiful crystals, which is like all those minerals we looked at before the break. But minerals make up rocks, right? So rocks are basically like a combination of a bunch of different minerals together. And that's where we're headed right now. So rocks are classified by how they form. So there's 3 different types of rocks: igneous, sedimentary, and metamorphic. But today we're just going to work on igneous rocks. So igneous rocks are formed from crystallization of molten material. I know that probably sounds like a little intense, but all that really means here, I'm going to give you a hint. Let's guess. What do you think igneous means? My drawing skills. Wow, you can really tell that I teach art, huh? Boom. Volcanoes. So these rocks are really just magma or lava that is cooling. So when I say molten material, I'm just saying like liquid rock, basically. So when it says crystallizing, that's just taking this magma or lava and it'll take on the crystal pattern of whatever the chemical formula of the minerals that are inside of it. So basically it's just liquid cooling into a solid. That's what igneous rocks are. And the reason it's called igneous is because ignis means fire. So igneous. They're the most common type of rock in the whole planet because when the Earth first started, it was all just like molten materials. It was really hot. It was large bodies of planetary masses colliding against each other. And eventually, over time, we've cooled into rock. So most of the planet is igneous rock. But if you look inside the Earth, not everything has cooled all the way down yet. So inside the Earth, we're going to learn about this a little bit later too. The very center of the Earth is like liquid metal, basically. Liquid iron and nickel. The rest of it, there's parts that are like melty and liquidy, but a lot of it's just really hot, soft rock. And then there'll be pockets where there is just superheated magma and lava just dying to escape. And if there's a little crack in the surface where it can escape out of, then we have volcanoes. We have also, sometimes it's not just on the surface. We can have volcanoes underwater too. So there are 2 types of igneous rocks. There's extrusive and intrusive. So the first one's extrusive, and these are the lava rocks. So X, like exoskeleton, extrusive, cools on the surface, the outside of the Earth. The difference between lava and magma is lava what's already erupted and magma is still inside the Earth. So if we haven't erupted yet, we're still calling it magma. And then once it comes out of the volcano, then we'll call it lava. It's the same thing. It's just for us to recognize, has it erupted yet or not? So lava's erupted, magma's still inside the Earth. So if you're an extrusive igneous rock, you were made by lava. The lava's come out of the volcano, and it's cooling either on the surface of the Earth or underwater. There's a lot of underwater volcanoes, and that's like most of the surface of the bottom of the ocean is covered in extrusive igneous rocks. Think of like Hawaii. I'll show you some videos in a second. But extrusive, exo, outside. Sometimes they'll be called volcanic rocks. Same thing. Usually these rocks are porous. Porous means they have holes in them, like pores. Think of like SpongeBob, covered in holes. Our first one we're going to look at is called basalt. Walter's going to help us. There's Walter. So this is basalt. This is more than one piece of basalt. See all the little holes in it? So what those holes are little spots where gases escaped when the lava was cooling. I'm going to show you an experiment in a second so you can kind of see how this works. But those are 2 pieces of basalt. Okay, so I'm going to show you kind of how lava erupts from a volcano doing a Diet Coke and Mentos experiment. If you want to do it from home, this is all the stuff you'll need. So you got to take the Mentos and you got to put it in something that you can drop it in. You can drop in one at a time, but it's probably going to start exploding before you get many in. So if you can find some kind of tube where you can drop in a bunch at once, that's how it works the best. So I'm going to fill up this tube. It's graduated cylinder, I mean. Okay, so you need something to put underneath this so I can flip it over. Won't need my gym card for a minute, so I'll use that one. So you're gonna put it underneath whatever tube you're using. And you go like that so you can stack it. So what I'm gonna do is I'm gonna put it over the Diet Coke bottle. And what happens is all the water in the Diet Coke is gonna rush to the Mentos and try to dissolve the outer coating. And as it's dissolving the outer coating, all of the carbon dioxide, all those bubbles in the Diet Coke, remember you breathe out carbon dioxide, all that's gonna escape. So as it escapes, it's gonna shoot up in the air and take all the liquid with it. So that's basically what happens in a volcano, is there's a bunch of gases dissolved inside of the magma underground, and once they find like a crack where they can come out of, all those gases try to shoot up and go to the surface and get where there's less air pressure, and as soon as they get up there, they take the lava with them. All right, so here we go. Just in case.
What?
My raincoat.
Okay, so what am I doing?
Come here. I'm gonna hold this. You're gonna open the bottle and then run away.
Okay. Now?
Okay, next time we'll put in the whole pack. So I found a little piece of extrusive igneous rock out here. It's a piece of basalt. So can you see all the holes in it? That's how those holes formed. It's the gas that was escaping out of the lava. So once the liquid starts to cool, all the gas that was there has escaped and it leaves holes where the bubbles were escaping out of. It's kind of like when you like cook a pancake, you see little bubbles coming out. All right, so we're gonna try it again. Add a little more Mentos. That was the best one.
Yep.
If you want to do this at home, go for it. Film it. Send me some videos. It works best with diet soda. You can try it with different ones if you want to compare how high they go. But in my experience, diet soda works the best, and mint Mentos. It was a pretty cheap experiment. Cost like $1.79 to do the whole thing. But make sure when you're done, clean up your mess. Send me your videos. So there's more than one type of extrusive igneous. The other one that everyone wants to talk about, obsidian. I know you little Minecraft kids. So obsidian's pretty cool. It's very glassy. So basically any extrusive rock just has, you can't really see the crystals in it because they cooled so quickly. The crystals didn't really have time to form like the big structures you see in like quartz or something like that. They're either no no crystals or like glass. So this is a piece of obsidian. It's pretty cool. It's from Hawaii. The very top, see, it's all like glass over the top of it. So it's like obsidian usually forms when lava hits water. So it just immediately cooled. It didn't have like any time to form any real crystal structure almost. Oh, this is another piece of basalt I had in Walter's house. It's pretty cool. I got it from Hawaii. A kid brought it to me. But you see the top? It's just like a piece of lava that cooled on the street in Hawaii. So Hawaii, basically the whole island is just extrusive igneous rocks. So the island formed because it's over something called a hot spot. So there's like a weak spot in the crust of the earth, and magma breaks through and lava hits the surface right there. And as it hits the water, it turns into rock, and that's what builds the island. So really, Hawaii is getting bigger and bigger all the time, because every time you have a volcanic eruption and it hits the water, that lava turns into rock. So igneous rocks are really what builds the planet. This was like all our original continents and things like that, right? We have lava erupt. As soon as it cools down enough, then we have rock. So Hawaii's building and building and building and building. That right there is probably will have some basalt and obsidian. This is Kilauea. It's erupting almost constantly on Hawaii, and you can see just the rock building and building. The island not only gets larger, like width-wise, but also height. So these are all like cooled lava fields in Hawaii. So our second type of igneous rocks are called intrusive igneous. So intrusive, think like inside. In, like exo, outside, intrusive, inside. So these are the ones that cooled from magma. So if you look inside of a volcano, it's not like lava's just immediately shot to the surface and erupted. It's coming up over time. And sometimes it will never escape wherever it's trying to get out of. And it might slowly cool over time, but never erupt. So these are how intrusive igneous rocks are formed. So they're still formed from cooling magma, but it cools way, way, way slower. So this fact that it cools so much slower, it's able to build bigger crystals, because the crystals have maybe 100, 1,000, a million years to form rather than 10 minutes. So then we get rocks with bigger crystals. A lot of minerals are formed this way originally too. If you remember from researching our diamonds and things, a lot of minerals are formed from magma cooling slowly over time, or superheated water too. Magma heating up water and minerals dissolving in it. So the only one we're going to discuss right now is called granite. Granite is super common, even though it's expensive for our countertops, but it's because it's so sturdy. So granite is a mixture of a bunch of different minerals together that cooled slowly inside the earth. Usually there's quartz in it, maybe mica, maybe some biotite. There's a lot of different minerals in it, but the crystals are larger than you would see because they had a chance to grow. So there's Walter again. So we got a couple pieces of granite. So how you can see like the different crystals and like how it's structured together in kind of like a matrix. So that's more how granite looks. So like you'll see a couple different colors. Granite can come in hundreds of different colors. A lot of times there's whites and pinks and reds and things like that. But it can come in a wide variety of colors. Those are both different pieces of granite. They formed the same way, so they're granite, but it can have many different minerals in it. The difference between rocks and minerals are all the same. Every piece of quartz is the same, but rocks can have different structures depending on what's inside of it. So each piece of granite can be different. Here's Lucy. She's going to show us our granite countertops. So if you look at the granite, you can see all the different crystals inside of it. There's quartz in there. There's mica in there. There's biotite in there. There's multitude of minerals, but they're had time to cool slowly inside the earth, so they're compacted well. It might be somewhat porous, but it's not as porous as extrusive rock. So it's good for your counters, but you still need to seal it because there is some pores in it. So just a quick reminder, if the magma right, stuck inside the earth, if it cooled slowly inside the earth and didn't erupt, then it's intrusive. But if it did have time to erupt and cool quickly, then we have extrusive rock. So extrusive on the outside, cooled quickly. Intrusive on the inside, cooled slowly. So I went on a little walk through Armagosa Trail. This is Black Mountain. It's a dormant volcano. So this is like a little dormant volcano up by my house in Henderson. So I thought we'd take a walk up here and see what kind of extrusive igneous rocks we can find up here, since this was formed by a volcano. So if you look around, you see all like the dark rocks. A lot of times if you see a lot of dark rock mountain, this is called Black Mountain, then it's probably formed from igneous rocks. See all the holes? Those are the pores where the gas bubbles escaped. So if you want to try to find some igneous rocks on your own, especially extrusive igneous, we're just looking for rocks with little holes in it where the gas escaped. So that's most likely basalt. So the ground of this mountain is completely covered in basalt rocks. So it's not active anymore. It's not still erupting, but that was how it originally formed. I know when I was a kid, I found out that it was formed from a volcano, and I had nightmares all the time it was going to erupt on us, but it's not. It's dormant. But this is in Henderson. I'm going to show you in a second. Right there is where Harney is. That's Sunrise Mountain. So you guys are on the other side of the valley. But if you ever want to take a walk up here, it's a pretty little trail. It's called Armagosa Trail. I found some other rocks up here. See how these are also basalt, but you see how they're turning this like orangey color? These rocks have oxidized. Do you remember when we talked about that when we did chemistry? Oxidizing is when something reacts with oxygen, remember? So that means there is probably iron in these rocks that have reacted with the oxygen in the air or oxygen in water, and they have rusted. So if you see any rocks with like orange or red in them, they probably have a pretty high iron content in them. So that's pretty much all about igneous rocks. Go on and try to find some granite, try to find some basalt, send me some pictures if you find any. I'm going to send out a little slideshow where you can add some pictures of it. Here's my husband getting a little kendama trick to end the day out. Have fun in quarantine. Keep your distance from people. Stay safe. Love you.
Ah!
Good job, boo.
Thanks.